In this example, we're asked to show that the harmonic series, which is the series from 1 to infinity of 1 over n, diverges. And I'm going to use the integral test to prove it. So remember that the integral test only applies if the terms are positive, continuous, and decreasing. For all values of n, in this case, greater than or equal to 1. So I'm going to put some question marks here. Is it positive? Is it continuous? And is it decreasing? And when I say it, the expression that I'm referring to is this 1 over n expression. And so if we're thinking of this as a continuous function of x, I'm going to write it as f of x equals 1 over x. Typically, when we write an expression of n, then it's implied that n is an integer. When we write an expression of x, typically x is any real number. So we can assume, though, since this is a sum from 1 to infinity, that x is greater than or equal to 1. We're not worried about what happens when we plug in, say, -3, because that's not part of this sum anyway. So is it positive? Yes. If x is greater than or equal to 1, then 1 over x would certainly be positive. Is it continuous? So we'd be concerned about continuity when x equals 0, but if we're taking a sum from 1 to infinity, then n is always greater than or equal to 1, or in this case, x is greater than or equal to 1. So yes, it's continuous over that entire interval. And is it decreasing? Yes. As x gets larger, 1 over x, the reciprocal will decrease. So it is positive, continuous, and decreasing. So once you verify that, that means you're allowed to apply the integral test, which means we can determine the convergence or divergence of this series by looking at it instead as the integral from 1 to infinity of this function 1 over x. So this is an improper integral. We need to express it as a limit. So I could express this as the limit as t goes to infinity of the integral from 1 to t of 1 over x. And that's equal to the limit as t goes to infinity of the antiderivative of 1 over x, which is natural log absolute value of x. Although I see that x is greater than or equal to 1, so I don't really need absolute value. I'm just going to write natural log of x. Okay, where this is evaluated from 1 to t. So this is equal to the limit as t approaches infinity of natural log of t minus natural log of 1, which one thing about natural log of 1, we know for sure it's a finite number. In fact, natural log of 1 is 0. Now, as t approaches infinity, natural log of t approaches infinity. Natural log is a very slowly increasing function, but it is increasing without bound. So this limit here is infinity minus 0. So the integral diverges, which means the series 1 over n, and going from 1 to infinity, diverges by the integral test.